A great day to start the events here at KubeCon plus Cloud Native Con. And I just want to give a big hand to Lisa Marie-Nampi. Can we all just say thank her so much? She put this whole thing together. It's done a great job. And I just wanted to offer that. You're welcome. So perhaps what we just do is just introduce everyone on the panel. We have Saad of Google. We have Dean Paron of Azure and Sandy Amin of IBM. And we were talking a little bit beforehand, and I was wondering maybe if we could each just talk to you about your own particular perspectives. Saad, you've been really involved in the Kubernetes movement since its beginning. Dean, you come from the background and really in building out cloud storage architecture, thinking about hybrid approaches. And Sandy, I would say that one of the things I get from listening to you is about a lot of these customers out there who are dealing with these very stateful environments and how you can help them transition to that. So just a few industry observations, and I think the first one is pretty obvious, that enterprise customers want to have choice. Is that true or no? Do you want to have choice? Does that matter to you? Yes or no? Raise your hand if yes. Oh, not everyone. Well, yes, pretty much, but yeah, who is sure? Really. So maybe the first question should go to you. So tell us about those early days of Kubernetes, and when I know you were just joining Google at the time, and there was this beginning to see this shift happening, right? And we saw the rise of Docker, and we saw the rise of how do you kind of manage all these containers in these different types of environments, and that really then brought us to the Kubernetes. What was your observations at the time that have you reflect upon today and where we're going?
So in those very early days, I think it was extremely obvious that with everything that Docker was doing, there was a revolution starting. And at that point, I think a few of the folks in the community, early Red Hat, Google, started realizing that there was an opportunity to try and build something on top of this, because just container technology alone is not sufficient to actually run containers at scale on distributed systems. And with the I guess the background that we had at Google and running distributed systems, we decided that we're going to take the power of Borg and kind of build it into this product called Kubernetes. And when it first started, I don't think we had a clear answer for what persistent storage and stateful workloads would look like in this system. But we started to evolve this API very rapidly, build it in tree into Kubernetes, and like Steve alluded to earlier in the day, it was like 7 members of this team that were writing all the controllers, writing the API objects, and we came up with a set of patterns that actually have served us very well since. They've allowed us to abstract away the implementation of storage in a way that makes it easy for application developers to write applications that are portable across different environments, but at the same time allow the power of the underlying storage systems to still be exposed to the cluster administrators. And since then, it's been a challenge to try to make that more scalable. We started with in-tree volume plugins, and then we moved to Flex and to CSI, and that's kind of where things started.
That's and in those early days, there was a lot of questions, I think, about how do you think about storage, wasn't there? I mean, and so today here we are, and I was just curious, Dean, from your perspective, you guys have come a long way in terms of your approach to container technologies, and I know that you're building container technology as kind of a core part of your own infrastructure. Mm-hmm. Perhaps you could talk about that and the challenges that you've looked at, and how you're thinking about that now as you look more towards hybrid approaches.
Sure. So, in Azure, I work on the storage and edge team. So there's a unified team within Azure that builds our baseline storage technologies, and then also builds our edge platforms, which are Azure Stack and Databox. We're looking at, I think, first of all, I think the first thing I would mention is that enterprise customers, I saw we did the survey here of how many people are trying to deploy enterprise applications into containers. I think the way you asked it was how many people are doing it. The survey I saw the other day was 75% of enterprise customers are trying to do it, right? And so what we're seeing in Azure is just this overwhelming set of enterprise customers who are just struggling to manage their classic enterprise workloads, like these just monolithic, non-microservices style workloads. And there's this enormous amount of energy and momentum to rewrite them into some sort of a microservices container-based architecture. And one that may not always live exclusively in the public cloud, right? I think all the major cloud vendors are also investing on trying to build these hybrid or these edge architectures where you can have some sort of a container system or an orchestration system that extends from in the cloud, to on-prem and back. And so where I see a lot of energy and a lot of momentum right now is in trying to solve those types of problems. So
Sandy, I would like to ask you a question about Kubernetes itself and why you guys decided to make that real big bet on it. What was it really about it that led to that decision? And what are you seeing now as kind of the impact for customers?
Sure. One thing I'd like to mention is IBM was an early adopter of container technologies.
Yeah.
We had our own container service without Kubernetes or Docker Swarm. It predated that. But we saw the benefit of a standardized container orchestration system. And as a result of that, we've seen great benefits for both our internal services and our customers who can now have basically portability across hybrid cloud environments, both multi-cloud and inside their own cloud environments where they may have their own kind of infrastructure that they're setting up, but they're using Kubernetes as a common substrate for their applications. And really part of the other benefit I've seen is not just our internal services running on cloud so quickly to be in a DevOps kind of form, but also our customers who are now alluding to what Dean said, they're at the point of breaking down their applications into microservices, and they can do that slowly by bringing in just a couple of services and linking it in, all within the same Kubernetes environment and using storage.
Yeah, I'm seeing a lot of that.
Yeah. I just have I want to make sure that everyone here gets a chance to ask a question if you have one. I know sometimes it's tough to get to stand up and ask that question, but these are major cloud service providers here. Are there questions you have about your own deployments, about your own challenges that you face that you'd like to address here? And if not now, just think about it, because I think I think this is an opportunity to kind of discuss these matters. One of the overarching themes I'm wondering about is we've heard a lot about cloud native technologies, but there's different approaches, right? I'm curious about the approaches that you've seen work and you don't work, and maybe we can use that as kind of an overarching theme as we kind of discuss these topics. So Saad, perhaps you could discuss about kind of, from your own kind of historical perspective about working with, working on Kubernetes and seeing its evolution. I mean, when we were talking to, I was talking to Joe Beta last week or 2 weeks ago at reInvent, and we were actually in a container. There was this thing called IFX, this event that Packet did, and they actually had a Rube Goldberg machine, and we made this kind of comparison to Kubernetes at the time, right? And it was like, and so much has happened since then. I'm curious about the approaches that you've seen in your own experience that really have worked, or even, in some approaches maybe that you need to rethink again.
Yeah, I think the key thing for Kubernetes has been two things. One is a focus on end users and identifying who those end users are. Those are application developers, right? Instead of, I think somebody alluded to this earlier in the day, was in the storage vendor community, it's very natural to think that the consumer ends at where your storage system basically ends, and that's going to be the storage administrator, and that's it. But with Kubernetes, what we wanted to do was say, let's take a step back from that, and how are people actually going to use these storage systems? And that allowed us to focus on building something that will actually enable new use cases, right? The idea of dynamic provisioning was something that didn't really exist before. The idea that you can basically provision on-demand storage when you need it. So these patterns kind of emerge from that focus on the end user. So I think we started from that, and then what happened was we ended up realizing that in order for us to continue to scale, we're going to need to build consensus across the community, and this is something that's pretty challenging. The storage vendors are a difficult bunch to try to get to agree on everything.
Oh, come on.
So, and understandably so, right? Like nobody wants to come up with a standard that's going to be the least common denominator, right? You don't want your product to be crippled in a way where the full functionality of what you have to offer to customers isn't available. And so that was the challenge in building interfaces that would allow that power to still be available, but in doing so, the way that we did it was by figuring out who the end users were. Application developers don't necessarily need to be exposed to all the knobs that a storage system exposes, but a cluster administrator should be. They should have the ability to tune whatever custom knob exists on any particular storage system. And with those concepts in mind, I think we ended up building a interface that actually works very nicely at that lower level of exposing storage to a container.
Dean, I'm curious from your perspective on approaches that you've seen
Yeah.
effective or ineffective in kind of your own experiences.
Yeah, I mean, I'm reminded of the old adage, right? Like, how do you eat an elephant? Right? One bite at a time.
Yeah.
Right. Like the approaches I'm seeing fail, or rather the approaches that I'm seeing succeed is I work all day long with enterprise customers that have these like legacy systems that are 20, 25 years old that, at best, they've sort of moved into the cloud as like VMs, right? And now they're trying to figure out like, how can I re-architect this to like move better and to, get economies of scale and better performance and things like that. The approach that I see works well is they'll sort of leave the existing app in place. And then I think as Sandy mentioned, you start to nibble at it one bite at a time, right? You take off, like the example that I'm reminded of is I'm seeing really in a bunch of different industrial manufacturing scenarios, I'm seeing a lot of people sort of taking their existing enterprise manufacturing apps and they're trying to implement concepts of real-time detection and AI and machine learning to try to do things like identify bad parts as they go down the assembly line, right? And rather than re-architect the entire app from scratch, they'll basically tackle this new problem that they're trying to solve, with like a new Kubernetes cluster that they'll kind of roll out, and then they'll integrate that back into the main app. And then once you kind of get one of those early wins, that sort of makes it easier to kind of extend out and kind of do the rest of it. I mean, the joke is, I was talking with somebody who owns a bunch of the container technology in Azure, and one of the most common questions we get, frankly, is still, what's the difference between VMs and containers, right? And I know in this is not the audience for that type of a question, but it's perceived as being so complicated that having an approach where you can kind of bite off a little bit and then kind of go more and more and more after that, I think is the one that I'm seeing having most success.
That's fascinating. Sandy, I'm curious from your perspective on some of the learning lessons you've seen from customers and what they've learned along the way. And one of the approaches we take, at least when we write our ebooks and such, is we think about the people and the teams and the work and the workflows and how the technologies, fit with the teams and their own workflows. I'm curious on that, from your perspective.
I mean, in IBM, we work with a lot of customers trying to transform themselves into a full DevOps pipeline. One of the key facets that's been very simplified for them is dynamic provisioning in Kubernetes. The ability not to talk to an administrator to get storage, and they can just put that as part of their pipeline. It's like really incredible. And the trend I see next is now they've mastered that, they're actually now saying, well, I need to run my application with my storage on these particular nodes. So now the Kubernetes actually has lots of features with integration with a scheduler and writing schedule extenders. You can see a lot of the vendors here, they write their own orchestrators. So it gives the customers a lot more power of how they can place their workload to a storage. And where I see things going in the future is what customers really want is self-managed and self-managed applications with the data. So now that you'll have that, there's an emergence of application operators occurring. Mm-hmm. And I see that as a third trend. We're at the beginning trend of getting people comfortable with static provisioning. It's going to get into placement, and then it's going to go to a lot more higher level abstractions moving forward.
So, I mean, this, from that perspective, then I'm curious from anyone's experiences in their own team development and how they've kind of tackled some of these issues. Anyone out here who's running? Can I get a show of hands who else is running in production, this container-based enterprise applications with stateful environments? Would you mind, we'd love to get your perspective. Well, there's a lot of them. No, there are a lot of them. You know, yeah, no, I'm curious. No, I'm curious if you have any questions for anyone. I mean, on the panel, when as it relates to kind of the experiences that you've had. Yeah, question.
Or an answer.
Or an answer.
Can you give them a minute to think about it?
Sure.
Okay.
Sure. I'm just I'm hoping that we can just see if there's anyone out here who can talk about this, you know, from their own experiences. But this idea of stateful workloads, these containerized databases, like, why do customers want this? Why do they want, you know, why do they even care? I mean, what is wrong with the old way of doing things?
Again, to Alex's point this morning, there's no such thing as a stateless workload. Something always has state, so you always have to deal with storage, right? So that's why storage is so important in having it simplified for them as part of their pipeline.
So I think what I'm starting to realize is that abstractions are a very nice way to be able to speed up the velocity of development at the next layer. And Kubernetes introduced an abstraction layer that you know, allows you, it's the classic principle of separation of concerns, right? But there are more abstraction layers that still need to be developed. So Kubernetes abstracted that lowest layer of making storage available inside of a container, and it's done a pretty good job with it, with dynamic provisioning. It's extremely powerful. But ultimately, customers don't care about that. What they care about is, how do I run my database on a Kubernetes cluster? And the way that you do it today is different for each application, and it requires somebody with deep Kubernetes expertise to figure out, and requires some sort of custom controller to be run on top of Kubernetes and operator. And those patterns haven't really been standardized today. So I think the next opportunity that we're going to see is going to be around that, figuring out what that abstraction layer looks like at that application layer for stateful applications, and then kind of mindfully merging that with the layer that we've exposed within Kubernetes and at the lower layer with CSI.
Anyone else care to comment on that?
Yeah, I mean, we sort of transitioned here into like trends and where we think things are going, which I think is kind of interesting. You know, I'm seeing a lot of momentum around this concept to the edge, right? There's this sort of whole class of like old school, old world, like enterprise style apps that like live in these old school data centers. There's all this native, born in the cloud, you know, stuff that's born in the cloud. And like, those are two worlds that are fairly kind of well known, right? And then there's this sort of emergent wave of technologies, you know, on the edge, which include things like autonomous vehicles and high-def cameras and all these places where you're generating like lots and lots of data, but you're in a place where either the latency or the bandwidth of the cloud is like a huge problem, right? Like a driverless car can, you know, generate 50 terabytes of data a day. You're gonna put that over an LTE connection into the cloud? Probably not, right? You know, even you know, 5G helps a little bit, but not with things like latency. And so, you know, I think the other frontier, which I think all three cloud vendors are just actively working on, is how do we build and deploy these tool chains and these development tools and these orchestrators that can work not just in the cloud or not just on-prem, but that can kind of span across the gamut and even out to you know, edge-style scenarios where maybe you only got like one or two nodes out in a garage somewhere. There's just a ton of momentum and energy around that space as well.
So different devices, in a sense, in the future is what you're really talking about.
Yeah. So that relates to workload issues, doesn't it?
Yeah, I mean, you just have all sorts of challenges. You know, if you've got, you know, if you got two nodes from a cluster like out in a random garage that autonomous vehicles are pulling into, everything is different about that environment. I mean, the latency is different, the bandwidth is different, the power and the ruggedization that you need is different, the temperature controls are different. I mean, we're stepping beyond just kind of what can you do with an orchestration layer, but you also need an orchestration layer that can kind of, you know, kind of stretch effectively from the cloud out to these remote nodes as well. Everything's different about a scenario like that.
So what are some of the customer success stories that you've seen, Sandy, out there?
I deal with a lot of customers that are bringing their solution from the lift and shift world into containers, and they've been able to do things fairly rapidly with their application. You know, whether it's trying to link in with a database, the fact that the databases are already packaged in a way that can be easily installed with Helm. And the fact that Helm, which is one of the vehicles besides operators to install applications, they already deal with storage for them inside there. So you don't even have to deal with that storage piece because that's been codified in a sense in some cases in the Helm install. And the abstraction that Kubernetes provides lets it easily move from cloud to cloud. Mm-hmm. So I think that's been useful for customers to say, I don't have to deploy the database. They can focus more on the business logic instead.
Any questions at all? First, okay, we got two actually. Well, I saw you in the back first, and with the fellow in the glasses.
Oh my gosh, furthest away.
Okay. So all three of you guys have your own Kubernetes engine service, and you have compute services, and customers are running Kubernetes on those compute services, but they're also running it in your Kubernetes engines. Do you think, do you know what the sort of percentage is between people using the engine versus the compute, and that relationship to people using your container, your CSI interfaces? So people taking advantage of your block storage, do you find that it's that the people using the engine are going to use block storage more than or other storage services compared to the ones using compute? And does that, going back to your point about the vendors, the storage vendors, having these knobs that they could potentially toggle, but you're bringing it down to the lowest common denominator, do you feel like there's a level that you could address for people who want to stay on your Kubernetes engine using your storage services? And how do you hold back the reins? And
how do you balance?
How's that?
Is it how do you balance?
Yeah, how do you balance that? So I guess it's two questions. One is the people who are using it, and the other is how do you guys balance the control of being the large cloud providers who could shift away from that lowest common denominator?
Maybe I'll respond to a couple of points. The people that are customers that are coming into our cloud, they have different types of workloads. Each of those workloads have different needs for storage. So Kubernetes provides a nice abstraction through their storage classes to either have file or block or object. So we offer all three that customers can have in our Kubernetes service. That's one thing. So what's the percentage of them using the Kubernetes service versus the drivers or the storage classes, if that's one of your questions? Getting back to what Alex said, my gut feeling is about 40 or 50% that need some type of state, whether they're deploying an application or they're deploying an application dependency of their application that indirectly needs state. They're going to be consuming some storage in the end. So again, from a control point of view, I think the power is within the user on what they want to use and how they choose to use the various abstractions in the orchestration layer and exploit them.
Yeah, I mean, I would add, I want to look, your question's a good one. I want to go back and look up the percentages of how many people use the kind of roll your own Azure container service versus using AKS. I actually don't know the percentages. I do know that the managed Kubernetes service is like one of the fastest growing services that we've got in Azure. Kind of looking at some of my support people here, and they're nodding their heads as well. So there's at least, from my view, like anecdotally, like kind of going through like the finance reports, like there's a lot more buzz and there's a lot more seeming growth like on the fully managed Kubernetes side of the house, for sure.
Yeah, and on the Google side, it's very similar, Deans. I don't have the exact numbers, but the Kubernetes managed solution is growing very, very quickly. And I think the last number I heard was something like 40% of workloads are stateful on GKE. And to the second part of your question, I think you were asking along the lines of there is this kind of standard abstraction that Kubernetes provides, and a lot of storage systems are implementing with CSI. And I guess your question was, would cloud providers step away from that?
Since you guys are all engines, you have the option of building into your engine something that does it in a non-standard way. That maybe cuts out 4 layers of objects and storage management.
Okay. So to restate the question, it's since you're a cloud provider, there is a possibility that you could cut out multiple layers of abstraction. Is that something that you would do? I think more and more we're being driven towards standards, and that's what customers are asking for. So it's unlikely to happen. I think what we're actually going to see a move towards is a push for more standardization. Like Sandy mentioned, that it was block and file are very well abstracted within the current Kubernetes API, and that's because the data path was standardized a long time ago in the operating system, right? SCSI, POSIX, those are standard data path APIs, and Kubernetes came along and built a control path automation around that. And ideally, in the future, we want to extend that beyond just block and file to other storage ways of accessing storage. But the challenge is, of course, you can't expect the data path to already be standardized. So if you think of various object stores, for example, each one of them has a different standard for their data path. And if there was some agreement on at least the data path, then we could incorporate very similar patterns into Kubernetes for accessing and abstracting away and making portable object storage as well, and potentially message queues and databases and things like that.
Great. Let's get one more question. I know this gentleman here, you had a question, didn't you? Yeah. And in your responses, I think it'd be nice for people to know what are some of the investments that you're making in storage that people may not necessarily know about.
Okay, so my question was really, since you guys are the public cloud providers and we are a huge private cloud shop, so to say, and we all have the dream of getting hybrid cloud happen. You guys are trying to get into enterprises, and enterprises are trying to get into public cloud. The major challenge has been, out of many, is around data. Right, you can abstract all you want, all other layers, but your applications are going to live where your data is going to be. Yeah. So how do you guys think you can solve that problem so that you can get into enterprises?
Good question.
I could start with this one. I'm curious. Are you looking to keep your data on-prem, or are you looking to put your data in the cloud?
As long as it's secure, I don't care.
As long as it's secure, I don't care.
Yeah.
So all the major cloud providers, all of us and those of us that are not represented here, all have these like massive storage transport appliances that you can get as well, right? Do you have 100 terabyte? Like there was the question before we even started, how many people even have like 1 terabyte running in Kubernetes? Yeah. And it was like, well, one hand like went up, right? Everybody's got like 100 terabyte or larger storage transport appliance. So if you need to get your data into the cloud, you call up any cloud provider, and for like a couple $100, they'll send you an appliance, you copy all your data onto it, you send it back, and that's now effectively like a commodity service across all the different cloud providers. And I would say you're right. There's a strong recognition, certainly within my company, and I suspect the others too, that the data has gravity, right? Where the data is where the services are. And so I'd say we're all investing in ways that we can kind of do two things. One, ways that we can extend our cloud microservices, containers, Kubernetes, everything. We're investing in ways that we can extend some of that from the cloud out to you, because there are going to be scenarios, no matter what, where the data is going to stay on-prem. Could be compliance, could be latency, could be bandwidth, could be any number. It could be you don't want to put it in the cloud because you compete with the person that builds your cloud. Right? So for any number of reasons, there's going to be some data that's going to live on-prem. And so there's one series of investments, which are how do we take all of our cloud stuff and extend it out to work with you on-prem? And then the other half of that equation is how do we give you better tooling or better physical stuff to help you move your data into the cloud so that it doesn't need to be there in the first place, right? There's the old adage, right? The best bandwidth is a busload full of tapes going down the highway, right? Like that's still true.
Sounds like a song.
Yeah, it's true though. But like for these large data types, that's still true. Like it's hard to get a petabyte of data into the cloud. as you said. So we're kind of on the Microsoft side, we're totally investing on both sides of that equation.
Did everyone get a chance to reply? Do you guys want to?
Maybe one point I want to make is, I mean, all the cloud providers, as Dean said, they're trying to make it easy to move applications between public and private clouds and also across clouds. Part of that is also security. So there's a lot of investment, that is still continuing to happen across the security area, data security area. And there's things you can even do today with the capabilities that these public cloud providers provide, like things like bring your own key encryption. So the power is in your hands. Even if you decide to move the data, it can still be encrypted on the public side with your own key, and that's in your control.
Yeah, on the Google side of things, we're definitely investing in on-prem going forward. I don't know if you heard about GKE on-prem, but the idea is that we take this managed service that we have in cloud, which has been, taking off like crazy, bring that convenience on-premise to data centers. And the challenge beyond that is, okay, we have data that is now living on-prem, we have data that's living in cloud, how do we bridge that gap? And like Dean said, there are tons and tons of different solutions on all the various cloud providers to try and enable that, from actually shipping a box to you and then having that shipped back to things like in Google, we acquired a company this year from Israel called Villastrata, where they will stream a block device, a VMware block device from on-premise to the cloud within an order of 5 minutes. And it'll basically act as a cache that slowly starts pulling your data, and you could basically migrate your application to the cloud within minutes. So you have a lot of solutions at your disposal, and we're going to continue to invest in those as we move forward and keep an eye out, basically.
Excellent. Well, give a big hand to Saad, Dean, and Sandy.